Hello to all my dear friends and respected viewers. I'm Shayan Satt, and I'm here with the first episode of Arduino tutorials for you. You've probably seen my video with Benjamin B. and Ali Doyle on the Doyle channel, Robot Wars. If you haven't seen it, I'll put the link up here so you can definitely check it out, because this is the first episode of the Robot Wars series. While I was working on building the robots based on your suggestions in the Robot Wars video and the suggestion of my close friend Ali, I decided to make some tutorial videos on how to build these robots for you as well. On the Jahe channel, ever since I created it, the plan has always been to provide technology tutorials and similar content. I never got the chance before, and this is the first video in a new series that will be uploaded to the Jahe channel. In this video, I want to teach you in simple terms how you can build a remote-controlled car for yourself using Bluetooth, Wi-Fi, or even radio, which you can later turn into a robot. So if the Robot Wars competition is held, you can participate in it. To build a remote-controlled car, we need a few components. Roughly around 4 or 5 small parts, which you can get for under 2 million tomans. To start off, I just want to give you a brief explanation. In the first part, we'll get familiar with the components and materials we need. In the following sections, I'll explain to you step by step how to connect these parts together. What things should you keep in mind to prevent your components from getting damaged? What steps should you take to make sure your robot works properly, your remote-controlled car has no bugs or issues, and how do we get started with Arduino programming? So to get started from the very beginning, I want to introduce the components to you. In order for us to build a remote-controlled car, you need a brain. What does brain mean? The brain is the Arduino itself. It's a microcontroller to which you give instructions to perform certain tasks. These instructions are given using very simple programming languages. You can teach that brain to carry out these commands. For building, we can use several types of Arduino. Arduino comes in different types. From the early series of Arduino, which are known as Arduino Uno and Arduino Mini. That was many years ago. I think it's been about 10, 12, or even 15 years. I myself got to know them around 10 years ago, and they are the grandfathers of the robots you just saw in the Devil video. This machine you see here, I built it, I think, for my university project. I built this during the early semesters of my bachelor's degree and submitted it as a project. It was the first time I got acquainted with microcontrollers or Arduino, and I realized what a fascinating world it is and what cool devices you can make with it. One example is this very remote-controlled car. You can use it to make smart components. I don't know how to make automatic mechanisms. So many things. It's impossible to even name them all. There are just so many things you can do with it. To start, I want to show you the different types of Arduino boards that I have here with me. I'll also mention a few other types, and I'll put their pictures next to the video so you can see the different models on the screen. So that you can get a closer look, I'll also put their names on the screen to make it easier for you. The first Arduino I have here with me is the Arduino Mega, which is a more powerful version of Arduino. It gives you more pins so you can connect more components to it. This Arduino Mega isn't necessary for this project. It would be overkill and more than what we need. This is a newer type of Arduino that has come out, which also includes Wi-Fi and Bluetooth. That means they've added Wi-Fi and Bluetooth directly onto the main board itself, so you can activate them using code and make use of them as needed. For example, you can connect to it as a modem. You can use it for IoT, the Internet of Things, to smarten up any components you like, or just use it for simple tasks, like what we did in Robot Wars, using it as a Bluetooth or Wi-Fi controller. This type of Arduino that includes Wi-Fi and Bluetooth is called ESP32. Now there are also older versions of these which were called ESP8266 if I'm not mistaken. This ESP32 version, known as ESP32CAM, comes with a camera, so you can use it as a camera or a small webcam. This board has both Wi-Fi and Bluetooth built in, meaning you can connect to it via Wi-Fi or connect it to your modem and exchange your data with it. It even has a slot for a memory card, so it can store the video files it captures through the camera onto that memory card. This is another version that you can, for example, use to build a remote-controlled car, but it's very small and it might be difficult for you to use it. There's also another version, which is this small one. It's newer compared to the ESP32CAM or ESP32CAM or the camera version. This version is the ESP32S2, and its mini version is very small in size, but it still provides you with Wi-Fi and Bluetooth. You can connect this one to the same remote-controlled car and use it. For now, I'm just telling you this, so you get familiar with building a remote-controlled car like the one you saw in Dolam. First of all, you need to decide how many wheels the car you want to build will have and with how many wheels it will move. Usually robots or cars have 2 to 4 wheels. If you use only 2 wheels, you can only control forward and backward movement. You'll need to add a caster wheel so you can also handle turning left and right. But if you use 4 wheels, you'll have more flexibility when it comes to turning left and right. Of course, this mechanism doesn't have a steering system. We use code to give the mechanism the ability to turn left and right. To begin, once you've determined whether your robot has 4 motors or 2, you can use these motors. Use nets. Now, depending on your needs, get 2 or 4 of them. I'll show a picture of these motors in the video. These are 6-volt DC motors, and the maximum voltage they can handle is 6 volts. We can actually give them more than that too. But the problem that arises for them is with the gearbox inside. The cheaper gearboxes are made of plastic, they wear out, get ground down, or break, or the motor overheats too much, which can cause the gearbox to jam or even burn out your motor. That's why the maximum voltage you give, it should definitely be 6 volts. So it works for you in the long run. If you go above that, it might work the first time, maybe for 10 minutes, or even an hour or a day. But when the heat is excessive, this motor gets hot and burns out. It doesn't burn out instantly. It depends on how long it's being used. The higher the voltage applied to it, the greater the chance it will burn out. So that's why you should always consider 6 volts as the maximum for these. If we use 4, like in this car we have here, and install 4 motors for it, we need a controller that can send commands to these motors to make them move. This is called a motor driver, or sometimes a motor controller. This one is a dual motor version, which allows you to control 2 motors. To be more precise, I'll put its picture up on the screen for you. Here we have 4 screw terminals, and these 4 terminals are for our motors. 2 positive and negative terminals for the first motor, and 2 positive and negative terminals for the second motor. We also have 3 inputs for power or voltage. One is for 5 volts, one is for 12 volts. 5 volts means you supply 5 volts to this input, and you use it for control, which results in the motor running at a lower speed. It won't have high speed or much power. There's also a section for 12 volts, which we use more often so we can supply a higher voltage. Why? Because when we supply 12 volts to this, it gets divided by 2. That means it gives us 2 outputs of 6 volts each, which allows us to get the maximum power from the motors we have, if there are 2 motors. This is nominally 12 volts, but it can handle up to around 33 or 34 volts. However, my suggestion is to supply it with a maximum of 20 volts. For controlling it, we have 4 pins here, which are specifically for communication with the microcontroller or the brain of our device. Now, this could be an Arduino or the ESP32 that I explained to you earlier. These 4 pins control the commands for motor 1 and motor 2, as well as speed and direction. What does that mean? The first 2 pins are for commanding motor 1 and motor 2. The third pin is for the motor's speed. The fourth pin is for the motor's direction. What does that mean? When we connect these 4 pins to our Arduino, we can control this driver through these 4 pins. Let me give you an example. You give the command, for instance, pin 1, which is for motor 2. Let's say it's set to a speed of, for example, 200 units, which if you've watched the dual videos, I mentioned that we have gears in robotic or electronic cars. The gears are in the form of PWM. PWM stands for pulse width modulation signal. That means we send a pulse, and based on that pulse, the voltage level determines the increase or decrease in speed. We connect this pin to the Arduino. For example, in Arduino, we specify that its speed should be, say, 150. So out of the maximum of 250, if we set it to around 40 or 45% less, it gives us an initial minimum speed. That's why our first motor starts moving at a speed of 150. The last pin, which is the direction pin, reverses the motor's movement. What does that mean? It means we tell it to move forward. The motor moves forward at the speed we've set for it. Then, for example, we can tell it to go in reverse, to go backward, meaning it should move in reverse, counterclockwise, which causes the direction of the motors to reverse. That is, it switches the motors positive and negative. I mentioned that this motor driver is for 2 motors, but you can also connect 4 motors to it. How You just need to connect your 4 motors in pairs, wiring each pair in series. That means you connect the positive and negative terminals of the 2 motors that are next to each other together, and then connect them to this driver. This way, those 2 motors will be recognized as a single motor by the driver, and you'll have the necessary power. But if you want to control 4 motors separately to handle each one individually, for example, like off-road vehicles that have 4x4 written on them, meaning all 4 wheels move independently, you need to use a different motor driver, which is called a motor shield driver. Now, I'll show you a picture of this driver. It's inside here right now. In the next part, I'll open up this car and show it to you. That motor shield driver, whose picture you can see up here or on this side, it's specifically designed for Arduino Uno. In other words, it's made for the older Arduino, not the Arduino ESP32, which is the new series that we want to use to build the Bluetooth or Wi-Fi car. So in order to connect this motor driver to the new board, there are a few steps involved, which I'll definitely explain to you in the upcoming videos. Another question that many of you have asked is, what components make up an RC car and how is it built? What issues are there with its battery? How should we make the batteries? To build an RC car, we need 4 different components. First is our motor. Second is our motor driver. Third is the brain that controls the motor. And fourth is the battery. Now, there are other parts like the body, wheels, chassis, and so on, which you can either buy or make yourself depending on your preference. For example, you can take a board like the one you see on this robot. It's just a simple board that I used for the chassis and mounted the motors on it. The next step is our batteries. For the car's battery, it's not necessary to use knife batteries. Use a rechargeable battery or power bank, as we explained in the dual video. You can also use AA batteries, but the problem with using AA batteries for us is that each AA battery is 1.5 volts. This 1.5 volts is the voltage that these batteries provide us. When fully charged, we need to put 4 of these batteries together to get a voltage of around 6 volts, which is basically the same 5 volts I mentioned to you earlier. This voltage is enough to start and move the car, but it doesn't provide the power and speed we need. And since the devices and components we've installed consume a lot, it will only last for about half an hour to 40 minutes at most, which is still less than what we want. If you increase its speed, if you increase the speed of the motors, turn up the sound of the engines, these 4 batteries won't be enough for a car. For example, you would need to use 8 batteries. Then once the batteries are depleted, you just have to throw them away. It's not economically viable, and these batteries don't meet our needs. That's why, as we showed you in the dual video, we use power bank batteries. The same batteries that have been used in all power banks and are still being used. Of course, a new generation of lithium polymer batteries has come out, which are thin like phone batteries, but these batteries are the ones even used in Tesla cars. Unlike AA batteries, they are not single use. They are rechargeable. Their voltage is not 1.5 volts. It is 3.7 volts. And 3.7 volts is the nominal voltage of this battery. What does that mean? You can buy this battery under the name 18,650 battery. Now, you can get this in electronic stores, market sections that sell electronic components, and websites. And it comes in different versions and sizes. There are various brands available. There are cheap Chinese brands. There are also good brands like Samsung and LG, which are more expensive. This battery is 2,600 milliampere hours, and it's from the LG brand. These rechargeable batteries have 18,650 printed on them. 3.7 volts is the voltage when these batteries are discharged or empty. When these batteries are fully charged, their voltage reaches 4.3 volts. When you use this battery, as the voltage drops, the percentage on the display, if you have a battery display, also decreases. For example, if this battery reaches a voltage of 3.7, it means the battery is empty and has no energy left inside. In order for it to have energy, it definitely needs to be charged up to a voltage of 4.2. Why does this happen? They are calling 3 and 7. 3.7 is the nominal voltage by which these batteries are known, whereas their actual voltage is 4.2. There are also different types of this battery with various milliamp ratings. This one right here is the 2,600 milliamp hour version. We also have 1,000, 1,500, and even 3,500 milliamp hour versions of these batteries. These batteries come in different amp ratings, meaning the amount of current they can handle and output. Give me an output, discharge. There are batteries, for example, that are labeled as cone amp, which means they can provide you with 1 amp of current. If it's C2, that means it can provide you with 2 amps. It can provide you with 2 amps of current. If it's C3, that's 3 amps. If it's C5, which this model is C5, it means it can discharge up to 5 amps at a time. What kinds of devices is it used for? For devices that have high power consumption and draw a lot of current, like for example in the robots we used to build, where the parts needed to move quickly, they had to have high current. We needed C5 or C5 to get 5 amps, but you could, for example, use Cone or C2. This is the version I have in my hand right now. It doesn't have any advertising print on it, but it does have a label showing the voltage, type, and other details. Now I'll bring you another model that also has advertising printed on it. Right here, I have several models of these batteries. These batteries being sold in the market under the Sony name, but I don't think it's actually made by Sony, because from the quality of the print and the plastic wrapping, I'm sure Sony didn't make this. I'll also show you a close-up image of this part or this section so you can see it up close. Now, something is written on this battery. It says Sony rechargeable model 18650, and its capacity is listed as 10,000 milliamp hours, which is impossible. We can't store 10,000 milliamp hours of energy in this size here. Just from this 10,000 claim, we can tell it's fake and not genuine, but its quality is good. Even though it's counterfeit, the tests I've done on it have been good. Its power is about as good as those original ones. From the tests I've done, the quality I got from this battery is around 1,000 to 1,500 milliamp hours. So for this 10,000, you should remove a zero. This is 1,000 Haridun. For example, on this battery, you see it says 4.2 volts, whereas this original battery from LG says 3.7 volts, which is the nominal voltage, and is printed on all genuine 18,650 batteries. But this one has listed the full charge voltage as 4.2, which makes many people mistakenly think that this high voltage will damage their device. Is it possible for it to burn out? All of these are assumptions that come to your mind just because of this label. In fact, all of these batteries reach 4.2 volts when fully charged, and their discharge voltage is 3.7. I also have another version. I have another model of these batteries that is actually lighter than the two I just showed you. I think its brand is DP. Now I'll show you its picture again. Here's a close-up of this model's label. It's a lithium-ion battery model 18650 with a voltage marked as 3.7 and a capacity marked as 6800 milliamp hours. But this 6800 is just a nominal value and it's incorrect. We actually need to remove one zero from it. It's around 680 milliamp hours, but you could say it's actually less than that, maybe even lower. This is the type of battery we need for the robot, or in this case, our remote controlled car. So how many of these batteries should we use for this car? You see, the number of batteries depends on the voltage you need. For example, if we only needed 4 volts, just one of these batteries would be enough for us. But if we need around, say, 10 or 12 volts, we had 3 of these batteries, which were enough for us to get 12 volts. In the fully charged state, we consider its full charge. We say the maximum is between full charge and discharge, meaning it should have about 50% charge. We consider it as 4 volts. 3 times 4 is 12 volts. 4 times 4 is 16 volts, 5 times 4 is 20 volts. That's also why, in this case, the battery we made for these dual robots is the one we're using. There are 5 battery slots so that we can receive the base voltage from these batteries. Now, how can we get 20 volts from these batteries? Batteries can be connected together in 2 ways, in parallel and in series. What does it mean if we connect these batteries in series? That means in series, meaning the positive of this battery is connected to the negative of this battery. The positive terminal of this battery is connected to the negative terminal of that battery. Connecting batteries in series increases our voltage. The first battery, which is 4 volts, is connected to the second battery. With the second battery, it becomes 8 volts. When it reaches the next battery, with the third battery, it becomes 12 volts. When it reaches the next battery with the fourth battery, it becomes 16 volts. When it reaches the next battery with the fifth battery, it becomes 20 volts. But you also need to keep in mind that all your batteries should be of the same brand. That means don't use one of these batteries and then another different one. For example, don't use one of these really fake ones. Don't use the really counterfeit ones. Why? Because, as you've seen, their capacities and milliamp ratings are different. They're not the same. This causes one battery to drain faster than the others. Let me give you an example. You put the original battery first, the fake battery in the middle, and for instance, a semi-original battery at the end. The middle battery will run out faster than the other two, and when it does, it cuts off the current. Even though the other 2 batteries still have charge since this battery is depleted, it doesn't provide any current. And that's why the device stops working. It won't turn on. It shuts down. That's what happens. So my suggestion is to always use the same type of battery. If you're buying fake ones, get all of them fake. If you're buying original ones, get all of them original. Don't say, I have 2 fake ones, I'll just get 2 more originals, and together they'll make 12 volts or something. No, that would be a mistake. It will work now that it won't. But for example, in the middle of operation, the voltage might suddenly drop and it'll just cut off. The robot will shut down. These kinds of things will happen to you. That's why I recommend you use the same type for all of them. Now, in our series, we increased the voltage. We went from 4 volts to 20 volts, but the capacity of our batteries is still the same 2,600 or 2,000 milliamp hours as written on them. we say 2000. Even though it says 2600 on them, we call it 2000 milliamp hours. So if we put 5 2000 milliamp hour batteries together, that makes 10,000 milliamp hours, right? That's wrong. Why is it wrong? Because we connected them in series. When you connect batteries in series, only the voltage increases, not the capacity of the battery. If you want to increase the battery capacity, you have to connect the same number of batteries in parallel to your existing batteries. What does that mean? It means we need to connect another set of 5 batteries in series to our previous set of 5 batteries in series. We add it in parallel. What does that mean? Suppose, for example, that this is a 5-cell battery pack. The batteries are also placed inside it. It gives us 20 volts. Its milliamp hour capacity is 2,500 milliamps. When you want to increase this to 5,000 milliamps, you need to have another battery holder just like this one. Just like this one. Exactly 5 more batteries that are connected in series, giving 20 volts and 2,500 milliamps. But how do we connect these two together? We don't connect these two in series anymore. Because if you do, your voltage will suddenly jump to 40 or 45 volts, which can burn out your device and electronic components. To avoid making this mistake, make absolutely sure that they are connected in parallel and only then insert the batteries. If these are connected in series and you put 10 batteries into these 2 5 battery packs, you will definitely burn out your board. So how do we make sure these two are connected in parallel? This pack connects to this pack with positive to positive and negative to negative. When you do this, your voltage remains constant. You still get the same 20 volts even though you're using 10 batteries, but your milliamp hour capacity increases. What does that mean? It means you have 20 volts plus 5,000 milliamp hours of battery capacity. In other words, you've doubled the milliamp hour capacity that your original 5 batteries were giving you. By doing this, you can create a battery pack that provides both the voltage you need and supports the duration you require. If your battery pack gets discharged too much, recharging it will take longer. It might charge slowly, not charge at all, or your batteries could develop problems. So my suggestion is never, 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 never let your batteries get completely discharged. That means don't just keep playing with the car until the point where, for example, when you leave the car off the ground and the wheels are spinning in the air with no power, and even then it stops spinning in the air. When the wheels stop completely in the air and come to a full stop, it means you fully discharged the battery. And it's possible that the voltage has dropped below the minimum required for charging, so it might not be able to recharge itself anymore. So keep this in mind as well. Don't use these batteries down to the so-called last drop. Leave at least 10% charge before recharging it. Just like with phone batteries, where they say you should always keep your battery between 10 and 80% for longer battery life. So with this explanation now, you also understand about the batteries. To control these cars, you can use your phone's Wi-Fi or Bluetooth. Now, the versions of Arduino that I'm introducing to you, and I'll show you more in the next sections, come in different types that can connect to Android phones. Just connect to your iPhone. It can connect to older versions of Android, or it can connect to the newer versions of iPhone. There are different versions available. The version we used in the Robot Wars was a board. This was the ESP32ST board, meaning the 3rd generation of ESP32 or ESP32, which we were using. It has low energy Bluetooth called BLE, which is a type of Bluetooth that uses less voltage and consumes less power for optimized performance. However, many older phones do not support the BLE version of Bluetooth and use classic Bluetooth instead. The BLE version, if I'm not mistaken, was added starting from Bluetooth version 4 or 4.5. We had BLE Bluetooth devices, and now all the new AirPods and new smartwatches use BLE versions of Bluetooth so that they consume less power. That's why with this new board you can only connect to newer devices and connect to an iPhone, because the iPhone's Bluetooth is only BLE, meaning from the very first version that was released, its Bluetooth was opened up for use by other devices. You had BLE Bluetooth, so that's why you can't, for example, have an older version like the Arduino Uno or even the Arduino Mega, which is just a larger version of it. This Arduino doesn't have Wi-Fi or Bluetooth at all. In order to connect to this via Bluetooth or Wi-Fi, you need to buy separate Wi-Fi or Bluetooth modules, connect them to this, and do the coding so it can use the Bluetooth or Wi-Fi functionality. In this car, which is built with old hardware from about 10 or 15 years ago, this very capability has been used. Now this green board that you see here, and I'll also show you its picture in this part or this part of the screen. This is the HC05 board, although newer versions of it have also come out. I think HC06, 07, 08, and 09 This HC05 is Bluetooth version 2.5, which is classic Bluetooth and connects to older devices, like for example, older Android phones. It connects to Android devices with, say, version 5 or 6, but it doesn't connect to iPhones at all. In fact, the iPhone's Bluetooth doesn't even recognize it. Now that this new Arduino USB board has come out and made things easier for us, there's no need to use that one. But if you want to use the original method, the usual way, I'll also write about that board for you. I'll explain its specifications to you, and in the next part there will be a more complete section about it. I'll explain all the components, all the potential issues you might encounter, and all the necessary parts. I think this video has gotten a bit long, so for the first video, I think this is enough. A brief overview of the components we're using, the equipment that's being used. I've given you some short information about them. I hope you enjoyed it. If you like this video, don't forget to like and subscribe. Support me so I can make more videos and provide you with more and better tutorials. And also remember to definitely watch the next episodes of Robot Wars on the Dual channel and support us. Thank you all. I'm Shayan Sad, and this was the first video of the new Jahesh series. Goodbye. Bye-bye.